Hello, good morning guys. For those of you wondering what's going to happen when you have a city circuit in which you have different power sources, okay, like in the case of handout number 2, the city circuits practice questions. So you have circuit number 6 having 3 power sources, and also you have problem number 7 in which you have 2 different power sources, as you can see in there. In both instances, I am going to use falstat in order to give you a demonstration on what is called additive and subtractive polarity. This symbol for the battery, the long dash indicates the positive terminal, and the short dash indicates the negative terminal. So at this point in time, we can see that we are going to call this one battery number 1 and this one battery number 2, and we can see that the positive terminal of battery number 2 is connected to the negative terminal of battery number 1. In this instance, we can see that these yellow dots that symbolizes the current flow is flowing from the positive terminal around the closed loop on this city circuit back to the negative terminal. This is called the conventional flow theory. In this case, the voltage rating of the first battery is 5 volts, indicated by this voltmeter right here, while the voltage rating for the second battery is 1 volt. Okay? So I added here, just for demonstration purpose, a voltage slider, which is going to allow me to change the input voltage. So in this instance also, we have another voltmeter connected to this 10 ohm resistor in order for us to be able to see how much is going to be the voltage that we are going to have across this resistor when we have this additive polarity and when we changed the input voltage. Okay, so as I said before, we have 5 volts on the first battery and 1 volt on the second battery. So in total, we have 6 volts. Let's see, like in this situation, let's see if we can increase this voltage to 10 volts. So if I start to increase the voltage, as you can see on this voltmeter, I'm going to increase my voltage to 5 volts. And at the same time that I'm doing that, please observe what's happening with the output voltage. Okay, so I increase my voltage to 5.05. So at the same moment that I was increasing my voltage on battery number 2, the voltage right here through my load was increased to 10.5 volts, 10.05 volts. Now, if I increase my voltage to the max, in this case I decided to say that my max voltage was going to be 10 volts, you can see that by all means, the output voltage that I'm going to have through my load is going to be equal to 15 volts. Now, as I said before, this is called additive polarity. And this is something that we often find in household, like in household items, like remote controls and flashlights and things like that, where we have additive polarity in order to get a higher voltage through the load. Now, in your case, also, like in this case also, let's see what's going to happen if we decide to have, okay, I'm going to be reducing this back to 1 volt. So what's going to happen if instead of connecting my battery 2 positive terminal to the negative terminal, like if I do the opposite, if I connect negative to negative, then what's going to happen? So I'm going to swap the terminals. And now you can see that the negative terminal of my battery number 2 has been connected to the negative terminal of my battery number 1. So in this instance, the output voltage is equal to 4 volts. Okay? So they are connected in a sequence which is called subtractive polarity. So the voltage on both batteries are being subtracted. Okay? So we have plus 5 volts minus 1 volt, which is equal to 4 volts. If I increase the voltage on my second battery, okay, so look at what happens at the same time. As I am increasing the voltage on my second battery, which is connected in subtractive polarity, I want you to see what happens in this case, okay? In this case, we have that actually, well, the voltage of both batteries are being cancelled out. This being the case, you can see that a small amount of current starts to flow in the opposite direction, and it's just because like this minus 50 millivolts indicates that this battery have a higher voltage than battery number 1. So if I were to continue to increase the voltage on my second battery, all the way up to the full 10 volts, then now you can see that I have been able to reverse the flow of current. Okay, so, and now I have this minus 5 volts. It doesn't indicate that we have a lack of voltage. It only indicates that our voltage is flowing. Sorry, I shouldn't say voltage doesn't flow. Voltage is just pressure. So that our current is flowing in the opposite direction than the original flow. So if I go to 0, you can see that now our current is flowing CCW counterclockwise. If I go all the way to 10, then our current now is flowing clockwise. Okay? But all in all, what I want you to have in mind is that this is called subtractive polarity. Okay? So if you have any questions, please let me know. And in the case, just to finish with this, like if I were going to add an additional resistor, I'm just going to duplicate. Okay, so I'm going to stop the simulation here. So I'm going to be adding another resistor right here, another 10 ohm resistor, and I'm going to be adding another voltmeter that I'm going to be connecting right there. Let's put some wires to it. One wire here, the other one there. And now let's see what happens, okay? Something else that I'm going to do here, I'm going to apply another power source right at this point, okay? Okay, so in this instance, we have a series circuit, and now we have 3 power sources. So this one, I'm gonna swap the terminals, so we can have additive polarity. Remember that in additive polarity, positive gotta be connected to the negative terminal. So this positive here, you can see is connected to this negative terminal, and then this positive here would be connected through the resistor to that negative terminal. So when we run our simulation, okay, here we have, I'm gonna swap these so you don't get confused. Here we have 10 volts. Here we have 5 and 10. So the total input voltage for the whole circuit is equal to 25 volts. 10 plus 10 plus 5, 25 volts. We can see that as well from the resistors, because in a series circuit, the total voltage is going to be equal to the sum of all the voltages around the closed loop. So 12.5 on that resistor plus 12.5 on this resistor give us a total voltage of 25 volts. If I were going to swap the terminals on this one, okay, and I have, let's say that I have like just 1 volt, just for the comparison purpose, because now I have 1 volt here, which is in subtractive polarity with this power source. From the actual resistors, we can see that our output voltage, the total output voltage, is equal to 14 volts. So let's see if that is true. 10 plus 5 is equal to 15 minus 1 volt on this power source is equal to our 14 volts. Well, that's it for today, guys. So I'm going to be posting this circuit so you can play with it as well. I wish you a nice weekend. Okay, bye-bye.